Hello, everyone, and welcome to the fourth session of our Technion Dialogues, an initiative organized by the Brazilian Technion Society. Our theme today is the next frontier for AI solutions, where we'll bring you great conversation on the theme of artificial intelligence and some of its applications. And we're doing that in partnership with Embrapi. My name is Salomão Iospi. I'm president of the Associação de Amigos do Technion Brasil, also known as the Brazilian Technion Society. We're a non-profit organization, and the Brazilian Technion Society is one among several Technion societies around the globe. Our mission is to foster support within Brazil's public in general for the Technion Institute of Technology in Israel and its activities. With our initiatives in Brazil, we hope we can bring Brazilian people, institutions, and even corporations closer to the Technion, and so promote exchange programs and research cooperation projects and enduring relationships among them. And this is one of the things we're doing here today. We also aim to help undergraduate and postgraduate students from Brazil who may have an interest in attending one of the most prestigious technology universities of the globe. And in doing so, we, the Brazilian Technion Society, will be contributing with Brazil's society by creating productive and long-term relationships between Brazilian institutions and the Technion. As you all know, the Technion, Israel Institute of Technology, is consistently ranked among the world's top science and technology universities. It was Israel's first university, founded in 1912, having Albert Einstein as one of its founders, so well before the founding of the State of Israel. It's hard to distinguish the history of the State of Israel itself from the Technion. And if today we recognize Israel as being the startup nation, it owes it in no small part to the Technion. With 18 academic departments in engineering, the natural sciences, architecture, and medicine, the Technion Institute is the powerhouse of technology and innovation in Israel. Sufficient to say that the Technion graduates founded and lead 2/3 of Israeli companies on the NASDAQ. At the end of this webinar, we'll have the chance of posting some information as to how you can contact us and learn more about our activities. Please know that we'll be providing a recording of this live webinar on our social media. And during the webinar, you can make questions to the panelists by using the chat feature at the bottom of your Zoom screen. We'll try to pass along those questions to the panelists in the last part of our conversation. So in today's conversation, we'll have the privilege to count with some distinguished panelists, among whom is Professor Alex Bronstein from the Technion. Professor Alex Bronstein, who likes to be called just Alex, is a computer scientist, engineer, inventor, and technology entrepreneur who works with theory and applications in academia and industry. He runs the Intelligent Systems Center and the VISTA Laboratory of the Technion Computer Science Department. In the industry, he participated in the launch of several startups, and since the acquisition of his startup Invision, he has been the lead engineer at Intel Corporation's Perceptual computing group, developing Intel's 3D detection technology, RealSense. He was a co-founder and is currently the chief scientist for the Israeli startup VideoCites, which offers internet video search services to companies. So Alex, welcome. And I will now pass the megaphone here to Dr. Jorge Almeida Guimarães, president of Embrapi, the Brazilian Agency for Industrial Research and Innovations, who will briefly talk about Embrapi's activities, and then he will introduce our other panelists. Good afternoon, Jorge, and the floor is yours.
Thank you very much, Salomon. Good afternoon to everyone. First of all, I would like to thank the Brazilian Technion Society and the person of Mr. Salomon Yospe and Mr. Pedro Gonchovsky for organizing and participating in this webinar. I also welcome our distinguished guest speakers. Embrapi has been building up a relationship with Israel since the visit of the Brazilian delegation to Tel Aviv and Jerusalem in 2018. In that occasion, we signed a memorandum of understanding with the Israel Innovation Authority that has given the opportunity to work together in getting Brazilian and Israeli companies to collaborate in search of technological solutions for their products. With this proposal, we have a second call for proposals open until December the 20th of this year in areas of mutual interest, including artificial intelligence. For those interested, please see our site. The idea of this webinar, as has been said before, is to consolidate a future partnership with Technion. As you will be able to see, Embrapi is ready to take a step forward towards a solid collaboration in the field of artificial intelligence with our colleagues from Technion Brazil and Technion Israel. I'd like to take this opportunity to introduce briefly Embrapi to you. Embrapi is a Brazilian agency for research and industrial innovation, is a private non-profit RTO, Research and Technology Organization, that has a contract with the Brazilian ministers, coordinated by the MCTI, our Minister of Science, Technology, and Innovation. We follow an operation model very similar to the Fraunhofer Institutes for Applied Research and Innovation. We coordinate a network of 61 selected research centers called Embrapi units. In these initial 6 years of operation, more than 1,000 projects have been contracted by over 700 industrial companies. Embrapi can finance up to one-third of the cost of the projects as non-reimbursable funds for the development of projects between our units and companies. The requirement is that industrial companies also provide part of the financing projects. In practice, the companies contribute with about 50% of the cost of each project. And this project must be attending the range of technologies readiness levels, TRL, between 3 and 6. Embrapi is also responsible for the coordination of the government's strategic programs sponsored with financial resource from the tax incentive program known as Informatics Law. In the area of this operates in the area of IoT and Advanced Industrial 4.0. Also, another program called the Route 2030 for strategic mobility covering automotive industry is also under Embrapi procedure. Most recently, Embrapi was invited by MCTI to coordinate a network of artificial intelligence that you will soon learn about it in this webinar. It is important to inform that Embrapi has a unique model of operation with a very small headquarters based in Brasilia, and 97% of our funds goes directly to our unit to contract projects with industries in a fast, flexible, and no bureaucratic procedure. This means, for instance, that the Embrapi units can actively participate in international collaborations, as long as they respond to demands of technological solutions presented by industrial companies that are willing to co-finance their applied research projects. Besides Israel, we have established several international partnerships with other countries, such as Switzerland, Sweden, United Kingdom, Canada, and the European Union. Therefore, my main message to you today is that Embrapa is ready to go deeper into the challenge of the new frontiers of artificial intelligence research. We are very enthusiastic in doing this with the expertise of Technion. Thank you very much.
Thank you, Professor George.
Clarice is
Thank
going
you.
to present our guest. Okay.
Yeah. Thank you, Professor. I would like to present Paulo Curado. He is the Director of Innovation at CPQD, responsible for the institution's innovation policies and technological development actions. His responsibilities include coordinating technological platforms and their road mapping, articulating connectivity and artificial intelligence areas. He is also responsible for strategies and ecosystems for smart cities, intelligent agribusiness, Industry 4.0, and the Open Innovation Initiatives. Welcome, Professor Paulo Curado.
Thank you very much, Clarissa, Mr. George, Professor Alex, our audience, Mr. Salman. It's an honor to me stay here to present you the recently launched network for artificial intelligence innovation from Embrapa. This network I will briefly present you something about this network. It was started with 70 units and the experience of more than 140 projects already executed. All units cover our country in some states of our country. The main proposal of MCTI, Embrapa Artificial Intelligence Innovation Network, is to spread artificial intelligence to Brazilian company, expanding support for company R&D projects, and increasing AI competences and promote also national competitiveness. Some benefit of this strategy. The first of all is one-stop shop philosophy, allowing easy access to AI solutions for company, simplifying the interface with Embrapa units. This network look for high AI capacity and lower cost for the customers via research sharing. It's look also for team cooperation of specialists using technical committee that will be created. Support company R&D activity with a focus on the startup and small company. And finally, establish and support national and international cooperation with AI R&D networks in other countries like Technion. At this point, this webinar will be an excellent opportunity for our institution to learn more for some AI initiatives using some practical examples. We appreciate the opportunity to stay here to present you, and I hope to be able to move towards this great partnership that I hope will occur in the near future. Thank you very much for this opportunity, Clarice, and I'd like to pass the words to Mr. Alex Bronstein.
Thank you, and thank you for the invitation. It's an honor and a pleasure to be here. Actually, I sit. My faculty is exactly the building that you can see on the right from Clarice's head. That white building, the Taub Department of Computer Science. So I would like to show you some ideas, some thoughts about how to do imaging in the era of machine learning. I don't like the term artificial intelligence. I don't know what it means, but basically I can tell you how I think we can design better cameras or better imaging devices. I call it learning to see in this data age, where we have plenty of data and plenty of computational resources under our fingers. So if you look at this device, on the left, this is probably one of the earliest imaging devices that humans ever constructed. This is called camera obscura. It was popular in Europe in the 17th century, but probably was invented in China a couple of thousands of years before. And you can say that the imaging devices that you see on the right, like this brand new Canon Mark IV DSLR camera, or actually if you just take your smartphone, for example, in my smartphone I have 5 cameras, and I'm sure that the number of cameras in this room exceeds the number of people by a considerable factor. Basically, these are marvels of engineering and technology, but conceptually they are very similar to the camera obscura. It's exactly the same design, we just got more sophisticated in the engineering part. So what you have inside, there is some optical system, some imaging lens that captures the light from the scene and projects it onto a photosensitive array of pixels, and the readout in the form of a digital image that you get from the sensor is sent to the screen, and you enjoy your beautiful picture of your children or grandchildren or your favorite pet. Basically, this is how these devices work. But with the availability of computational power that we have in our smartphone, in our pockets, basically in our devices, we can actually put some amount of intelligence between the sensor and the screen, and do some image processing. Actually, this processing happens without you ever noticing what goes on inside. But the raw image that you get from your phone is not as nice as what you see on your screen. Now, with the availability of additional computational power, we can start thinking about crazier directions. We can say that, okay, so let's increase this computational part of this image processing part, and allow our optics and our sensors to go completely crazy. So what we can do, we can actually capture something that doesn't look like an image. If a human looks at the raw data that the sensor produces, it can be something that is not even intelligible, and you need some reconstruction process, some computational process, in order to get an image. What you get in exchange is that you can do more sophisticated, more interesting imaging, and I will show you a couple of examples in a few minutes. What becomes more interesting is, until very recently, most of the images were intended for a human beholder. So I was looking, or you were looking at the screen, and I just wanted to get a nicer looking images. But now most of the images that come out of digital cameras are actually intended for some machine vision, for some, let's call it, artificial intelligence algorithms. For example, in autonomous car, there is a perception system. A big part of it is based on vision, and it is actually not only useless, but probably also detrimental to have a human observer in the loop. The car will be much safer, much faster, if some machine intelligence algorithm analyzes the images and takes the decisions. So now, if there is an algorithm that looks at the images, maybe this entire processing pipeline and this entire design of the optics and of the sensors that was built for a human observer, maybe it is not optimal. So basically, what would be interesting to do is to try exposing those degrees of freedom that we might have in this entire design of the system, and learn them. So you can tweak your optics, you can tweak your sensors. Of course, it is very easy to tweak the digital part that does the image processing, because it's all in software or maybe some hardware accelerated solution. And of course, you can do it in concert by simultaneously learning the imaging pipeline and the artificial intelligence part that looks at the image. So essentially, you are teaching the machine to interpret the image, and you teach the camera to produce the best image for the machine to interpret. So basically, they work in concert. They learn how to see, how to interpret the world for a specific task. These can be optimized for a specific end goal, for a specific task. And the images that you might end up receiving will look ugly or unintelligible to a human observer. Okay, so let me show you a very specific example. This was an application that I started my interest with in this field. So if you look at this device, right? Let me just remove the cover. Just look at it from the side. I'm sure you all have similar phones. The camera is actually the thickest part of this device, and it is actually the feature. It's obviously the feature that sells this phone. Apparently, what drives this multi-billion market is your ability to take a good picture or video in a nightclub, so in low light settings. And of course, you see that there is a tiny hole in the aperture of the lens where the light goes in. So at some point, you reach physical limitations. The resolution goes up all the time. We get 12 megapixel pixel cameras, and the sky is the limit. The devices are always becoming thinner and thinner, and eventually you hit a physical limit. You don't have enough photons reaching your sensor, so then you cannot see anything. So the obvious solution is just drill a bigger hole in your camera. But if you do this, you will be losing what is called depth of field. So if you focus your camera, as in this picture, on some object, let's say somewhere in the scene, then when the object moves closer or moves further away, your camera will suffer from short or far-sightedness. The resulting picture will be blurred. Okay, and the bigger is the hole in the camera you have, the bigger is the aperture, the more narrow is this range of depths where the image stays in focus. So this is called depth of field. Photographers call it depth of field. And bigger apertures receive more light, but they have narrower depth of field. So basically what we try to do is to create a weird optical system. We put a special optical element that is called a phase mask into the aperture of the lens. And basically what it does, it weirdly blurs the image. So in a way that some colors will be in focus at short distances and some other colors will be in focus at farther distances. So you have this weirdly blurred image, but one of the chromatic channels contains sharp information. So it is now up to a computational process to recover a sharp image from this from this input. And we can actually learn the design of this optical mask and learn the design of the post-processing algorithm simultaneously in order to produce the best result, the nicest looking sharp image. And let me just show you an example. This is what a regular camera sees, and this is what our camera sees with this phase-coded aperture of the lens. Okay, you can see that it is about twice sharper. And what is interesting is that there is additional information contained in this input image, because different colors become blurred to a different degree according to the depth. So this relative amount of blur of the different chromatic channels actually contains depth information. So again, by a different computational process, you can infer depth from this blurred image. And then you can again play this trick and learn the best optical system together with the best image processing algorithm that work in concert now to produce, to solve a different task, to produce a depth image. And what you get is these nice depth images. Of course, this doesn't come close to active sensors that project some light into the scene, but this is a single shot, single aperture passive depth imaging system, and it comes to close to state of the art result. And again, it can be manufactured with practically no additional cost on the hardware side, and some additional cost on the image reconstruction side. So another thing that I wanted to show you, of course, there are many interesting examples where these kind of solutions can work, and especially interesting examples are in active imaging systems, like for example in medical imaging, like ultrasound or MRI or CT, where some energy is projected into the object of interest to get an image. And if you need to project something, then you have additional degrees of freedom that you can learn. Is basically consisting in what exactly you are projecting. So, and this also holds for radio frequency for radar type of imaging systems, like in autonomous car, millimeter wave RF imaging cameras. So we did some work on this type of imaging applications as well. We tried, for example, to learn beamforming in ultrasound. So in ultrasound, typically the image is created by sweeping the scene with a focused beam, and that is slow. If you need to image a moving object, moving organ like heart, for example, getting high resolution in space and time is quite challenging. So basically what we learned are very weirdly shaped waveforms that nobody would ever configure their ultrasound machine to transmit those waveforms. If you receive them back and you just do the regular processing, you see just completely unintelligible image. But if you learn simultaneously with those waveforms also the way to interpret them, you get actually an image that is as sharp as the regular one, but requires 3 times less acquisition time. And we did similar things in MRI as well. In MRI, the physics, the technology is very different, but you also have many controllable degrees of freedom in the way you acquire your image, basically in the way you traverse that so-called K-space where the image is collected. And I wanted to show you one final example. So specifically for airborne cameras, drone cameras, you see this device. The drone holds a camera on a mechanical fixture that is called a gimbal. It is a 3-axis mechanical stabilization system. It actually gives you rock-steady images and videos, but this costs. So it costs the bill of materials, the weight that the aircraft has to take, and it also consumes power. And especially for tiny drones, this limits very much the battery life. So gimbaled cameras are really the golden standard for aerial imaging, but they are costly in all these senses. So basically what we try to do, we try to build a digital gimbal. So we essentially learn, we take a fast camera that works at high frame rate, and we take a burst of several images. So here the trade-off is similar to what we had with the wide depth of field imaging. If you take a very short exposure, you get low light, so your image is noisy, and it is not blurred because the exposure is short. If you take a longer exposure, you have much better signal-to-noise ratio, but the image is blurred, as you can see here. So this is what you actually get. This is an actual imaging from a camera that just sees this resolution target. And basically what we learned to do is to take images of specially designed acquisition times, and then a digital signal processing algorithm that from these inputs produces this output. So basically, at least in some settings or in many settings, you can completely remove the gimbal and emulate it digitally. So of course it reduces significantly the system cost of the imaging device. And again, it is very, very important for airborne cameras where every gram and every watt of power costs a lot. So I think I will finish here. I think my time is out. Just again as a main message, I think nowadays in the era of powerful machine learning algorithms and really widespread and almost free of charge compute power that we have at edge devices, I think we need to rethink how we build our cameras, how we build our imaging devices, and bring them closer, and basically bring them closer to the learning algorithms. Learn not only the software part, but also learn the hardware part, learn the camera design, learn the camera settings, and get better, more efficient imaging systems. Thank you very much.
Thank you, Professor Alex. Now we will receive, let me just do something before.
I have a question.
Sure.
Okay. The Paulo Curado question, do you have some experience using this technology with other kind of cameras like infrared to look for hot points?
Well, so specifically, so let me say a few things about other imaging modalities. So again, as I mentioned, we tried ultrasound and MRI, and also depth imaging, what we have been doing at Intel with LiDAR range cameras. So it's an active illumination system that transmits laser light, and then we see measures how much time it takes for the ray to return. And there are very crazy things can be learned. And we can really substantially improve the quality of the camera by learning both what we transmit some code, but learn that code, and also learn how to decode it to get the depth. But specifically with an infrared thermal cameras, what I'm involved in a project with a few other colleagues. We are trying to follow how plants grow with a multi-modal camera. So we look at we are using tomatoes as our plants, but basically it can of course apply to other plants as well. So we monitor them with thermal cameras, but regular thermal cameras, nothing crazy yet, and some other spectral bands. What we try to do is to associate automatically the part of the phenotype that is visible to the camera with the genetic sequences of the plants. But I haven't tried doing any computational imaging with thermal cameras. Could be a cool project.
Thank you, Professor. We will answer the next questions in the end of the webinar, and I think we will have a lot of questions. Next, we will receive the following panelist. He is Fernando Nicodemos from NCB Sistemas Embarcados. He is the CEO and founder at technology-based company, NCB Sistemas Embarcados, where he is the CEO so far. His main research interests are the area of embedded systems, verification and validation of critical systems, high-performance and embedded computing, real-time operation systems, design using hardware description languages for programmable logic devices, and artificial intelligence. Welcome, Fernando.
Hi, everyone. Good afternoon or good night. Thank you so much for the invitation to be here. Thank you for the Brazilian Technion Society, and welcome, everyone. Well, can I start here? Let me share the screen. Everybody seeing my screen?
Yes.
Okay. Okay, so I'm the CEO, as Gladys said, and founder of NCB. And I will say something about our experience with precision biological control with drones. Well, NCB was founded in 2006 as a technology-based company. We were supported by Incubaero, that is a company incubator here in São José dos Campos. And our first experience was the automation of the spraying process for agricultural aircraft. So we made all the automation of valves and everything related to the automation when it was done handily. So the people fly with the aircraft and keeps opening and closing valves, and we made it automated. So we reach the result of 20% less chemicals. So we optimized the whole processes, and we were service provider for spaces projects. Where is my formation? My master and my doctorate degrees are in the aerospace area. So we are here now at the technological park, Parque Tecnológico de São José dos Campos, is the second step of an incubator. So we graduated from the incubator and we moved to a higher facility. So we are here until now. Well, in these first years, we just learned really well how the innovation processes worked. So, but we just make a pivot time in 2013 when we moved from chemicals and started working with biological control. So we saw that this was the future and is the future. And we just found that people were doing handling. In other words, it was labor intensive. People must walk through the crops to deliver some small piece of paper and to deliver some natural enemies. So the idea is to use the natural enemy against the pest, you know. So we used our knowledge in innovation and technology and moved to two products. So we are the pioneers here, and we got a grant from CNPq, that is a government agency, a non-refundable grant. So we moved for a solution for agricultural aircrafts and for motorcycles. So with one motorcycle, we moved 20 people from the crops with just one motorcycle with the same job. At this year, we focused on biological control. Later, in 2016, the drones become more popular. And here we just started to see the amount of data that we must collect and to manage. So here is was a really the big decision for NCB, because here we started looking at the artificial intelligence, because we just saw the amount of data we must manage, and to make this happen more efficiently and optimize it, we will need some machine support. So we got also some grants from FAPES, non-refundable grants, and we became exporter of this technology to other countries like Central America and Europe. And we are here now. Well, basically, we are here in São José dos Campos, okay? Here in Brazil. We have a very strong team with basically with master and doctorate in all areas. So we work actually with software, hardware, mechanical, and mechatronics. And until now, we face some challenges. So, for example, how we increase efficiency and precision of this biological control, simplify operation, to make the releasing rate repeatable, because each biological input has its own characteristics. How we would provide digital tracking, how we scale this technology. We are saying in Brazil that we have 32 million hectares of soybeans, so it's impossible to make this by hand. How can we construct patterns, and how can we be sustainable, for example? Well, the idea is this. So we just got an integration. So from the drone, we moved to a higher level system, cloud-based system, where we can compile all this information from the very beginning, the monitoring. Now with images, for example, we want to identify pest patterns, for example, local monitoring, identify the past, measure the past to make good releasing, plan mission planning, and we can also make the releasing with drone, all autonomous. So with one button press, you can make the whole process, and the post analysis to make digital reports. And here is our experience where artificial intelligence is. So maybe in 2 years with connectivity, the 5G technology, you can imagine the amount of data all these will manage. So it will become impossible for one to look at this and say, well, what's the best point to make, best time to make the releasing? Is the past making some harm now, or are they doing some harm later? So artificial intelligence will help us a lot with this. So we will combine all this information, and the point is that the technology will say you not when to do, but how to do and what to do. So this system will do everything in order to optimize the pest management control and to optimize the products. So here is a fast example how it works. So we keep monitoring pests all manually now. We make the digital planning. We make the drone releasing of the biological input. The biological control happens. In other words, the insect attacks the other insects, and we get the reports. So here is the point. Artificial intelligence will identify these patterns and make a little difference in how to optimize the pest control in your future. Recently, I saw a news in the internet that India is already using artificial intelligence to reduce the use of chemicals. So this is a huge need in the world to increase food with less chemicals and more compliance to be more sustainable, you know. Well, very fast here, we just sell the equipment and the support with all this system, and we have a lot of releasers or technology to release each different biological input. And maybe with Technion, we have some interest of cooperation, like develop some algorithms for artificial intelligence to identification of pest patterns, maybe monitoring this pests more efficiently with electronic pests, computational imagining, data analysis, and other stuff. So I think this is the future. In Brazil, they estimated that in 10 years, the crops will be all automated with artificial intelligence and with all this technology. And I think this is our experience and maybe a roadmap where we are located. So thank you, and I'm open for questions.
Thank you, Fernando. We will open for questions after everybody talks. So now we will receive Johan. Johan, let me, one moment, please. Okay, thank you for unshare your screen. Johan Coelho, CTO and founder at Bem Agro. Passionate about technology, he is responsible for managing the R&D department, development of new algorithms and solutions through the application of computer vision, artificial intelligence, and its most refined techniques of machine learning and deep learning. Through image processing, they deliver actionable information to growers around the globe, integrating a unique ecosystem of technologies such as drones, satellites, and agricultural machinery. Thank you. Welcome, Johan.
Thank you very much, Clarice, for your introduction. Can everyone see my screen?
Yes.
Great. So first of all, I would like to greet and thank the organizer for the invitation and to be a part of such an event. It's a great honor for me to be here with you all today and having the opportunity to talk about our experience in artificial intelligence or machine learning, as Professor Alex mentioned. And it's a pleasure to be here together with renowned institutions such as Embrapi and Technion. Well, starting my presentation, I would like to share with you this short PowerPoint and tell you a little bit about our experience and story with artificial intelligence. So my story with artificial intelligence started about 3.5 years ago.
Johan, your camera is closed. Could you open it?
Of course. So our experience with artificial intelligence started here in Benagro about 3.5 years ago. At the beginning, Benagro was a technology integration company that has a mission of delivering and making drone technology accessible for growers all over the world. Although during this period, after extensive and excessive researches about applications to solve farmers' daily problem, we end up developing our own image processing platform as well as our own algorithms. So before starting to share with everyone our experience, I would like to talk about what's artificial intelligence and where we are today in terms of technology. So when everyone starts to talk about artificial intelligence, we usually think that is something brand new. But artificial intelligence actually starts in the 50s with the beginning of the computer. And until the 80s, it becomes really popular. But we had some barriers that we have to face. And from the 80s until 2010, the machine learning started to grow a lot and begins to flourish. And in 2010, the deep learning techniques was really a breakthrough driving for artificial intelligence boom, right? So if we think that, for example, one of the main libraries developers are used to work with, such as TensorFlow, we had it in 2015. So we can see how it's coming really fast and how it's important for several industries, right? So Benagro as an agriculture company and as an artificial intelligence company develop applications for the agriculture and food industry. And why artificial intelligence for agriculture and food industry? According to UN, the United Nations, and also FAO, that is the Food and Agriculture Organization, by 2050, so we're talking about 30 years from now, the world population will reach the mark of nearly 10 billion people. And the demand for food will increase, it will increase in a certain way that is proportional, right? So there is no other way to produce more food without applying technology and without applying artificial intelligence. So our vision is increase activity in agriculture, the necessary quantity and quality of food for the next generations. And how we intend to do that? We intend to do that offering accessible solution in image processing through artificial intelligence for a more sustainable and productive agriculture. So I will talk about a little bit about our pillars. So Benagro works with agronomic reports and as a service provider as well. And in the really base of it all, it's machine learning, computer vision, artificial intelligence, and R&D. and we dedicate a lot of our time in research and development, which brings us to our platform. So as Clarice has mentioned at the beginning of the introduction for the webinar, Bem-Agro developed a unique ecosystem which is possible to integrate drone solution, satellite solution, and agriculture machinery. So all the information we gather and all the algorithms we apply on the images can be inserted in the machinery using autopilot technology, and including make a link with Nico's presentation about the automation process in agriculture. The autopilot is already a reality on farms all over the world, not just Brazil. So we are responsible to integrate all this ecosystem in a unique platform that has only 3 workflows. That is map, analyze, and decide. So I'm going to share with you all now some case studies in our research we have made, an algorithm we have developed together with CPQD via Embropi, also was a very important help for us during this process. So we developed an application for detecting planting gaps in crops, and this is an example we have about a customer farm with the application that artificial are able to find and identify the gaps, right? So we can identify and quantify the exact amount of gaps we have in the parcels and all the spots of opportunity to seedling. There is a research that is very important as well, that 10% of gaps implies in a result of 3.4% in productivity in sugarcane. So in each 10% of gaps, you have 3.4 less productivity. Also, during this research, we were able to develop an algorithm that is harvest lines for autopilot. So this reality, as I mentioned in the previous slide, it's becoming really popular in Brazil and all over the world, that is using the GPS technology together with the guidance line to reduce the trampling on the machinery. So once we are able to make a restitution of the guidance lines for autopilot, we will ensure that the customer will not have trampling, since our algorithm draw up the line in the center of the biomass. So when the harvesting machine comes, you don't have trampling. So I'm going to show you a quick video of our algorithm in practice. So basically, it takes just about a few minutes to process. So I accelerate the video in order to make it easier to visualize. So here we have the line restitution. You can see that the line is in the center of the biomass. So when the harvesting machine will make the harvesting or collecting the sugarcane in the field, it will always pass up on the center of the biomass, which will reduce the trampling for nearly 0%. So in that, we made a proof of concept before launching this solution to the market. And I would like to share this data with you. The customer authorized it, just can mention the name for purpose of reserved information. So here's a customer area that he didn't have guidance line for autopilot. He had around 20,000 hectares without the guidance line. and we made an estimation by the parallelism between the lines, and we got the trampling based on the dimensions of the machinery of 2.5%, which means a lost productive hectares by trampling of 500 hectares. And if you get tons of sugarcane per hectares in Brazil, collected per hectare is about 85 tons. So, which brings us to the final number of total sugarcane on tons on these 500 hectares. That is 42,500, and the pricing per ton in United States dollars 17. So the customer were able to have a saving on $722,500. So this is a little bit about the algorithms we have developed together with CPQD and also Embrapi. And this is some data collected by customers that are currently using our algorithms. So what I can share with you guys about the experience of using artificial intelligence and its benefits to the company and obviously to customers as well. Previously, we had the application of this very same report. It was required local software, required a powerful machine from the customer, required also a lot of manual intervention, and up to 48 hours to have a result for each parcel. Okay, with artificial intelligence and machine learning methods, no software was required from customer. Don't also require any machine from customer. All the algorithms is hosted on cloud computing systems and web service. No need for manual intervention. So doesn't need to have a lot of people looking into it. Actually, this is also computer vision, right? It's bringing the human eye to the machine. And up to just only 30 minutes to have the result of each parcel. So it's a relative increase in productivity with artificial intelligence and machine learning techniques of 98.95%. Okay, so it improves a lot our company productivity and also the user experience. So it was a very good experience for us, and customers are really satisfied with the result and the algorithm. And to finish up my presentation, some benefits of artificial intelligence in which we had the experience of enjoying was increase of operational capacity or capability and bringing scalability, new vehicles for image capture as satellite imagery, which is very important in order to expand our area of our market share, and also the application of the artificial intelligence, the machine learning, computer vision, which brings us to fully automated image processing solution. Well, that's it. Once again, I thank Brazilian Technion Society a lot for the invitation, also Embrapi, and to be part of such an event. For me, it's a great honor. If anyone has any question, I'm available.
Thank you, Johan. Now we have some questions that we will address, so you can start.
Let me, Clarice, hi. Let me address a question then, and I think we can address this question to Johan and to Fernando and to Professor Alex Bronstein as well. the presentation we just heard from Johan, we saw application of AI improving normal protocols that, let's say, farmers go about in realizing certain things that are happening much faster than they would, and then having support for decisions also in a much more accurate way and a faster way. And when we heard Fernando speak, and also the example that Alex gave us, we got a sense of something that usually we don't think about when we think in terms of AI, which is the incorporation of AI, and specifically Alex was talking about machine learning to sensing devices. So even before we transfer the result of sensors to computing, we transform that image, or it could be that sound or any other thing, into very relevant information for another machine to process. My question here is going back to farming. For example, today the farmer buys seeds. We know how important it is for the farmer that the seed be a good seed. And what usually the farmer here does, they take a sample of the seeds, of tons of seeds they receive. They take a small sample, they put it in a little plot, and then they wait for 6 to 7 days for vigor and some 10 days for germination. And from everything that I heard, just by thinking of the application of AI to a camera, maybe we could capture information about vigor and much faster than waiting for a certain number of days. And if you apply that, now let's apply that same concept to normalized difference vegetation index that you use from satellites. There's a lot of other things that you could do in employing AI. So my question to the three of you is, will we have more specific AI applied to the camera, so that maybe the seed provider will sell us some camera that can compute vigor and germination and give us something much readily available, more readily available than we now have? Is the tractor manufacturer or the combine manufacturer going to increase the number of sensors and provide us a solution with AI? Or even the image that we get from the satellite? Or will we have AI as a system like we have today, an enterprise system that we use at the farm level? Will we have a more sophisticated enterprise system at the farm that's going to give us intelligence about all of these things? So I don't know if you could comment on that.
Of course, Salomon. What we have experienced here in the past 3-4 years in Beyagro is that the market is growing really fast about artificial intelligence. We always heard about different types of cameras and sensors, such as hyperspectral sensors or multispectral sensors that works with different range of bands that we are able to see and get more information from these bands, right? So, for example, you comment about the NDVI, right? The NDVI has been used in agriculture for almost 20 years. It's pretty common, right? But when you use a RGB camera containing the red, the green, and blue, you basically can see exactly what human eye can see. You're not working with bands that like infrared or red edge that can give you insight even before the human eye can see. So I see that artificial intelligence will put these sensors to another level, and it will contribute a lot with the development on new algorithms and applications, and how growers throughout the world use this technology, but as a tool to increase its productivity, right? So I think we are on the right path towards it, and it's a process of getting there. So I think we are on the way, and we can see that on a daily basis, and we have researches on that here as well, and development applications for this purpose, for disease, all based obviously on the index of reflective that the plant emits in specific conditions when it's pressuring, when it's suffering a pressure for a plague, for instance, for example.
Okay, great.
Yeah, Fernando, you want to add something?
Yeah, adding on what Johan said, I think we have two levels of artificial intelligence. So with the increasing of computational power and processing, we will use artificial intelligence to improve sensors, to provide good data and good information. So the second level will be gather all this information and to provide indexes and indicators. So I think we will have artificial intelligence of the artificial intelligence, and it will become more evident with the 5G technology, because the amount of data will be much more higher than we have today. So we simply will not be able to compile all this information received from sensors manually, So what will be, I think the future is information. So all this will gather information and say, do this at this time, and this is the best optimized way to do that. So I think artificial intelligence will work in these two levels, from sensors to the overall system. And it will come from the very beginning, from planting, from seeds, to controlling pests and imagery. I think this will be the process.
On the other hand, if you allow, Salomon, there is a demand for AI in the edge computing. Oh no,
I wanted
we develop.
to comment exactly on that.
We have a demand. It's an honor for us. I'm from CPKD unit that developed this application for Johan. But you have a demand to use to make some equipment that you can embark artificial intelligence and just in time to use this intelligence in the field. I think the challenge is not only the hardware, to increase the hardware, but to perform better algorithms to use inside this equipment. And sometimes I have a lot of equipment in the field. How to transform this equipment and smart equipment to use it. And the cost is an incredible thing. But it's a challenge that you have now to use. The use of artificial intelligence, it's crazy. The productivity is growing very fast. But we have some challenges before, mainly in regions where we don't have communications, very like connections. In the near future, probably you don't have it. It's a comment. Thank you.
Maybe if I may, a comment regarding that. So of course there are very wide data links that are available today, like the 5G technologies that were mentioned. But with that bandwidth comes at a price. So it has system cost, and especially it has power footprint, energy footprint that is very significant. So if you want to put an edge device that will stay in the field, I don't know, for months, battery powered, or I don't know, powered by some simple power source, 5G might not be an option at all, right? So and also bringing bringing some deep learning techniques like what was mentioned before to the edge device itself. Currently, it is practically out of question because that will drain your battery in no time. So basically, doing this kind of edge device processing of information, sensing and processing, and transmitting, I don't know, maybe a tiny amount of information after only the relevant part has been distilled. I think that's a very interesting challenge. I think that will really change the way sensing and vision-based solutions are going to look like. And there is a lot of room to improve. So just imagine our own visual system is about six orders of magnitude is more power efficient than any low power vision system that we can manufacture today. So we can definitely do better. I'm not suggesting that we should mimic biology, but we should definitely do better. And I think the closer we integrate image processing and image analysis with the sensing itself, the better we are going to be there.
Thank you. That's very good. Listen, we had several more questions, but I think we're getting to the end of our allotted time. I will maybe, before I pass the word to Pedro Wonchowski, chairman of Embrapi, who just joined us, I will just perhaps ask you to, Alex and Fernando and Johan, to make your final considerations. And perhaps, I think we visualize here, Brazil is a powerhouse in agriculture. We have companies such as Fernando's and Johan's dedicated to solving problems in agriculture. Just in soybeans, we have 38 million hectares being planted this year. And I have the sense that in institutions such as the Technion, where you have a powerhouse of computer science and engineering and other things, there's a great potential here of collaboration and producing great things together. So with that, I will, Alex and Fernando and Johan, if just leave it to you, your final words, and then Pedro, please jump in.
From my side, Salomon, just getting a parallel about what Fernando said, also Paulo and Alex, I think that the main challenge overall in talking about artificial intelligence frontier, that is the topic of the webinar, right? Overall, the main challenge, I think, is the volume of data, and also the necessity of getting these insights and information, mainly for agriculture industry, that is very sensitive over time, right? So it's how to process this amount of data, having restrictions on connections on remote areas, and have to get these informations really quick, because for growers, the value of the information, it's about time, right? So they have to have a window to act and solve certain problems due to the season and the crop timing itself. So I think this is the main challenges, and just getting a parallel between about what everybody has mentioned.
Great.
Well, I think from my side, the future challenges will include power consumption, of course, and mainly data management, I think. So this will be to bring good information, to provide better information, I think this is the main challenge. And thank you so much for the opportunity, and if anyone wants to keep in touch later, we can discuss a little bit more.
Great. Alex, any last words there?
Yeah, I have last word sounds really dreadful, but I hope not completely last. So I have two comments there. So obviously all the system and the data management considerations are extremely important in order to transform something from an academic exercise into a real working service or solution. But I think on the machine learning algorithms themselves, I think the farther we get from the rigid and very constrained supervised learning techniques, the more we'll be able to deal with large amounts of data, because the learning itself will require less amount of human intervention, less amount of curated data and labeled data and so on. So I think basically the dream situation would be just observing the data in the wild without any human intelligence, if you will, and inferring something useful for the humans about the underlying processes from the data without any human intervention. So I think we are very far from there, but there are significant breakthroughs in getting away from this rigid supervised training regime. And then another consideration is the interpretability of the models. So, for example, if the model decided that something happened, or some event or some object or some pattern was found in an image or in some other source of data, basically understanding why that decision happened, and if the decision, for example, is erroneous, what exactly led to that decision. So basically, this kind of interpretability and understanding of what was behind the decision-making process is also very important, if not for our own satisfaction or curiosity or feeling of safety, because we don't completely trust machine learning systems yet, but also from legal and ethical perspectives as well, to understand, for example, post factum, if some wrong decision was taken, who is responsible and why. I think that these are still largely unanswered questions, at least in the general setting.
Thank you, Professor Alex. Now you will receive Pedro Wachowski, Chairman of EMBRAP, who will do the closing remarks of our webinar.
Okay. First, I would like to congratulate the Brazilian Technion Society for the initiative of organizing this meeting. I had a chance to see most of it. Alex Bronstein, I would say. Yes. Probably the opening remarks were very interesting regarding the next frontiers for solutions using AI. We also had two Brazilian technology-based startups, NCB and Benagro, and the support of CPQD. And I noticed that both these new companies used funding from government sources in the first stages of its life. CNPq was mentioned, CPQD was mentioned, FAPESP was mentioned, and EMBRAP was mentioned, and that shows the importance of government-funded support for the initial phases of technology-based startup companies. EMBRAP in particular is, as probably you all know, is funded mainly by the Brazilian Ministry of Science and Technology, but also by the Ministry of Education and by the Ministry of Health, and has been a very successful experience in Brazil. It's 6 years old only, by which is basically government money. It supports private research and development in Brazilian science and technology institutions, most of them public science and technology institutions and Brazilian universities. So this link between the knowledge in existence in these societies and the need of the Brazilian companies, this link has been provided very successfully by EMBRAP in the last couple of years. So I would like to thank you all for the participation in this meeting, And in particular, thank Brazilian Technion Society for putting it together very successfully. Thank you all.
Thank you.